Okay, we're ready for the review sheet for Unit 7, preparing for the Unit 7 test. And yeah, I thought you would get a kick out of this since we watched a Mythbusters clip earlier on in the unit. Now, number one is to take the following spreadsheet and create a good statistical question. Write the question, answer it, and paste a screenshot of your best graphic display which supports the answer. So let's go to the first one, which is going to be the team roster for the Miami Heat. I apologize, my computer is a little slow today, so it's going to take a few seconds every time I change and click. Now, this is something where we're interested in, we're looking at their position, their height, their weight, their age. Now you've got to make a decision at some point. What question do you want to ask of this data? And then you got to figure out what's the best way to create a graphical display. Do I want to do it here in Google Sheets, or do I want to move it to CodeApp and do it there? So we'll make that decision in a minute. But first of all, we need to choose. I don't think choosing what college they came from is going to be helpful here, because just about every single one of them was different. Now we could just about anything else. Well, the jersey number is not going to be helpful. The position, you've got a certain number of centers and shooting forward, strong forwards and power forwards and point guards and shooting guards. I'm not sure that categorizing them by position, you don't have that many on the team. You've got like maybe no more than 5 of each position. And so your statistics are going to run the risk of not having enough people to really make it worth chasing that. Probably either their average height, their average weight, their average age, or their average years experience. Now, the thing you need to understand is that when I look at years experience and there is an R there, what does that mean? Rookie. That means they have 0 years experience. And so, yeah, I actually, you talk about cleaning the data, I would need to change that and make those zeros before I tried to do anything with it. Now, let's play with height, since that one came first. The thing that you would want to do is you would want to, now, if we're going to try and do things like average, let's see what all right. For some reason, I am, because I haven't chosen. All right, so we're into this example. Sorry, I had to pause there for a second. I drew a box around the height in inches, and I went up to Insert and Chart. And really, and I can go over here and pick my type of chart. I can do that kind of a chart, which, doesn't give me a lot of, it kind of shows me graphically, yes, but doesn't give me useful information. Especially if my good question is, so what's the average height? I can't really tell from this graph. And as I'm looking through some of the other options here, columns and bar graphs and pie charts and scatter plots, I can't really do what I need to with that. I can't make the kind of decision that I need to with that. So we're going to back up, and we're going to take this entire list and we are going to import it to CodeApp. So let me find CodeApp, if I can spell it correctly. All right, bet you didn't know that what it stood for. Common Online Data Analysis Platform. And we're going to try CodeApp. And we're going to create a new document. Now remember, we had two options here. We could either download it and then drag it and drop it in the middle of my CodeApp screen like that. Or I can go back here and I can click the upper left corner to highlight the entire spreadsheet. And I'm going to right click and copy it onto my clipboard. I've just copied the entire thing to my clipboard so that when I go over here, and I can go under tables and new table, and under the ruler I can say import case data from clipboard. That's, it's on the clipboard. So maybe I need to say yes next time. And again, this computer moves a little slower than the one that I'm normally using. All right, we're going to start this over again. Why do I get the feeling that I just blocked my ability to import like that? All right, we'll go back and we'll do this the old-fashioned way. I will take the file and I will download it as a CSV. We said that that is the best thing that it likes, and it should show up down here on my bottom left. There it is. There's the file. And so now when I go over to CodeApp, and I can just grab that and drag it and drop it right in the middle. And there it is. All right, so I have got the entire roster of the Miami Heat for the 2012 season. That was when they won the NBA championship, if I remember correctly. All right, so now we want to grab a graph, and we're going to take the height, and we're going to drop it down here in the x-axis, and we see that there's pretty much a range from 74 to 84 inches. Now, when I start doing stuff like doing the median and the standard deviation, or no, excuse me, the mean is what I want. The mean. So I know your mean is right at 80 inches, which would be 5'8". Yeah, that's interesting. And then you've got 2/3 of the team within 3 inches of that. So 5'8". So that would be 5'5" to 5'11". Now 74 would be 5'2". And those are your point guards. That makes sense. All right, so we can go that route. We can go the box plot route. I am interested to note that this thing skews to the left. That everybody lives up here, but you got a couple of short guys that are throwing the average downward, because the median would normally be 80.5. That would be the median. It falls right between 80 and 81. But the mean is 80, which means that these short guys are dragging the average down from the median. So, these are, when we start asking the question of what is the average height of a player on the team, or even if you wanted to not use language that implied mean or median, you could say, what is the typical height of a player on this roster? then you would have the ability to say, well, the median is 80.5 inches, but the mean is 80 inches because there are some shorter members of the team that is dragging the average down. So that's when we go back to this. This is how we're going to respond to it. First of all, we need the question, which the question is going to be the typical height. That's what I chose. Okay, so that's your good statistical question. And then the response would be that your median is 80.5 inches, but your mean is 80 inches because of shorter players. That 74 is 5'2", which it's kind of short, even for an NBA point guard. So the only thing that's left here is to clip and paste, perhaps this graph right here. You could feasibly clip and paste the whole thing just to show that, this is where the data came from, and then this is what it looks like in our graphic display. That's probably the better response. And you can make this a little more spread out, or if you want to, because there's not much spread to this at all. So I guess it doesn't technically matter how much you stretch it out left and right. This just, making it the same height makes it a better graph to put in there. All right, so that's what you would screenshot. All right, let's move on. We've spent more here than I really wanted to. And we're going to come back to this, I suspect. So we're going to blank that and come back in a minute. All right, next question is to basically do the exact same thing, but with a different spreadsheet. This one involves the G7. The G7 data is going to look like this, where you have the 7 countries in the industrial world that are the most developed. Russia was a part of it at one point, and they got voted off the island. And the European Union is sort of like hanging on the perimeter. They kind of they have a place at the table, but they're not officially a part of the G7 because there are issues about their quality of life that is not quite as fully developed as these 7 countries. So that's when you hear about a G7 summit. Of course, back in my day, it was the G8 because Russia was involved, or I guess I should say the Soviet Union back in the day. But yeah, this has been going on for probably, 40, 50 years. I think they started it back in the 70s or 80s. But anyway, so you have figures there like how much they trade, and all of these are U.S. dollars. Their nominal gross domestic product per capita. In other words, this is the earning power in U.S. dollars of each person that lives in this country. And so, I'm noticing here that United States has $65,000 per person earning potential, as far as contributing to the gross domestic product. Now, the Human Development Index is something that you would have to go and Google. There are a number of factors that qualify into this. that by the time you put this all together, it gives you a sense of which countries are more advanced than others in everything from the way that they treat their people to the kind of resources that they provide for them and all of that. The whole quality of living thing, which, by looking at the numbers, Germany is actually the highest ranking in that respect. And then you've got the population as of 2014 for all 7 of these countries. So, trying to figure out what is a good statistical question to ask here. We play with U.S. dollars and with population figures, but the HDI, that's intriguing. That's a decimal. That's not dollars. That's not people. That's a decimal representation of how, I guess if they had a rating of 1.0, they would be perfect in everything. So all of these are coming close, but falling a little bit short of it here and there. So the question is, my question would be, what is the typical HDI rating of a G7 country? And that allows you to look at things like standard deviation and mean and median, and try and figure out where's the middle, where's the center, the measure of central tendency. That's kind of what we're looking at. So I'm going to download this as a CSV. And then we can drag and drop him into CODAP. Drag and drop, bang. And I don't need that. And there is our file. All right, so now we're ready to chase after a graph. And like I said, we're going to do the HDI. And again, it really does not matter. Good statistical questions can be made about the trade figures, about the GDP per capita, about the population. All of these can warrant good statistical questions. So here I think I'm almost tempted to merge them. No, I can't do that here. I can't merge them because, here's what I'd have to do. I'd have to treat them as categorical. Now, what did I just do there? If I fuse them into bars, that's not helping me a bit. So I'm going to go down here and I'm going to go back to treating them as numeric. What I'm seeing here is 926, 924, 922. That's why I got 3 of them bunched up right there. Is there between 920 and 930. And I wonder why. I wonder why it's only giving me 2 decimal places there. That's probably a setting somewhere in there that I would have to change. All right, so let's look at what we can. We can do standard deviation. So the mean would be 9.1. And standard deviation is 0.0189. You might as well say 0.02. So from 8.9 to 9.3, roughly, would be where 2/3 of them live. So you would say that Germany is a little high and Italy is a little low, and everybody else is where the group lives. So that's one. You could say that it lives between 0.89 and 0.93. You could look at median, box plot. That tells a different story. That tells us that our median falls here at 922. It's got 3 above and 3 below, but this skews on the low side. But once again, most everybody lives, all right, half of them. Remember, standard deviation plus or minus 1 is 68%, but this box represents 50%. You can say 50% live between 905 and 925. So we have a median of 922 and a mean of 914. That means that you've got some guys that are further down. You know, if you're going to be high, it's not high by much. But if you're going to be low, it's going to be low by a lot. That's what the skewing is doing to this. So let's go back to this, and we had a median of 922 and a mean of 914. So we can say, you know, what was our good question? Our question was typical HDI for the G7 nations. And we discovered that the median was 0.922 and the mean was 0.914. So, you know, maybe somewhere around 9.2. Or, you know, not 9.22, but just 9.2. You know, and again, it's all in how you explain the data. Of course, you are going to want to screenshot both of these. You know, since this is such a small list, you can do that and this. And, you know, whether you do mean and median in a box plot or whether you do standard deviation, that's up to you. You're the one answering the question. The issue is, you know, do I have the data to back this up? Can I graphically display that I'm right? That's the issue. All right. Oh, let's see now. We have one more, don't we? I go back here. We have one here that has some U.S. data, and it's basically the same thing. So let's look at what we got here. Did I not open up? Yes, I did. Here it was. This is what, when you open up the U.S. data, I don't really need the map. I don't really need that. What I do need is this. And because there are so many categories, we're going to go in the corner and we're going to switch to case card view and try and decide. All right, so we have, all right, so you have education in years. You have education tertiary, secondary, primary, and less primary. Let me define for you what's going on. Primary is basically elementary and middle school. Secondary would be considered high school. And then tertiary is going to be anything above high school, anything college and up is going to be tertiary. And so, you know, you've got the female population, the male population, and then, you know, and of course, this is by state. Apparently, we're missing a state somewhere. I'm not sure what's up with that. But in any case, let's look at the ones who had tertiary that went on to college. All right, let's do a graph. And tertiary. And so this is the percentage of people in this survey that went beyond college, or went beyond high school. And you've got all of these states, and so you see that they kind of clump here from 17% in West Virginia to 39% in Massachusetts, and then there's this one District of Columbia, 50.1. That actually does not surprise me, because in order to live in the District of Columbia, which is Washington, D.C., that it is not cheap to live there. And basically, the people who live there are government employees and such. Now, they may not be senators, but there is a pure ton of government jobs in D.C. And so, and a lot of them require some level of education. So that does not surprise me in the least. Oh, what does surprise me is if D.C. is one of the 49, that means we're actually missing 2 states. But I don't feel like chasing after who's missing. Now, what we can do is we can do, let's see, we cannot make them into bars unless we want to make them, let's see what happens if we treat them as categorical. Yeah, we're going to wind up with more categories than we know what to do with, so we're going to leave it as numeric. And we're going to go up here, and we're going to, let's try a box plot. All right, now that's nice. You've got your 50% of the population has, 50% of the states have between 24.6 and 30.8% having some tertiary education. So let's go back to this page and let's form a question of this. I know that I keep asking about the typical. You can ask other questions, but it's just that, usually when somebody's looking at a stack of data like that, that's the first thing they want to know is where's the middle? Where is the typical person? So our question here is going to be, what is the typical percentage of people in each state with tertiary, there's a new word for your vocabulary, tertiary educational experience. All right, so when we start looking at the data as we have it here, one of the things that I like to look at is the mean and the median, and notice that they are so close, 28 and 26.9. So you might as well call it 27% and 28%. So we can say that typically 27 to 28% have this experience. No, that's not a question. That's a statement. All right, so that's our answer. And, showing it for a graph, we can say there's our mean and median. And now, I'm almost tempted to go back to this. Whoops. I guess technically speaking, it stops here. And so you could do something like that. And, just by seeing all of the states, you get the idea that, all right, you're going to have the better part of the 50 states involved here. And, as it is, you can hover over any of these and figure out, each individual state. There's New York with 32.5%. Um, so I think that we're largely done with that one. Now we're at 30 minutes, and so I'm going to take a break on this one, and we're going to come back in another video and finish the last questions. It should not take, I'm guessing, probably not much more than 10 minutes on that.